In this article, we find equation of coordinate planes. So, suppose that this is z-axis and this is x-axis and here this is y-axis and O be the origin. Here we find out the coordinate plane, equation of the coordinate planes. So first we find out the yz plane, equation of yz plane. This is the equation of, this is z axis and this is y axis. So this plane is yz plane. So first we find here yz plane, equation of yz plane. If we take any point on the yz plane, if we take any point on the yz plane, then x coordinate on this yz plane is equal to 0. So the equation of yz plane is x equal to 0. So this is the equation of the coordinate plane yz. Suppose this is x-axis, this is z-axis and this is y-axis. Now we find here the equation of yz plane. If we take any point on yz plane, we can see the x coordinate of this point is 0. So the equation of the yz plane is x equal to 0. Now we find here equation of zx plane. Now we find here equation of zx plane, and if we take any point, on the zx plane, then y coordinate on this zx plane is equal to 0. So the equation of zx plane is y equal to 0. So this is the equation of zx plane. We know that here this is x-axis and this is z-axis, and so this plane is zx plane. If we take any point on the zx plane, so the y coordinate is 0 of that point. So the equation of the zx plane is y equal to 0. Now we write here third equation of xy plane. So if we take any point on xy plane, so if we take any point on xy plane, then z coordinate of that point is equal to 0. So the equation of xy plane is z equal to 0. Here suppose that this is x plane, this is y plane, so this is xy plane. If we take here any point on this xy plane, so the z coordinate, value of the z coordinate is 0 in this point. So the equation of xy plane is z is equal to 0. Now we find here Now we find here equation of the planes parallel to coordinate planes. Here we find equation of that planes which are parallel to the coordinate planes. If any plane which is parallel to the coordinate plane yz, suppose we take a corner point of a room and length suppose that this is x axis, breadth suppose that this is y axis, and height suppose that this is z axis. When we take y axis and z axis, we get yz plane. So if we take, suppose that this is the yz plane and here this is the plane which is parallel to this yz plane, and this distance is small a, so the equation of the plane parallel to the coordinate plane yz is x equal to a. So first we find here equation of the plane parallel to yz plane. If we take a plane parallel to yz plane and this plane is at a distance small a from yz plane, so equation of this plane parallel to yz plane is x equal to a. Suppose that this board is the plane yz plane, this board is the yz plane, and suppose that this is the plane parallel to yz plane, and suppose that this is the distance between this yz plane and this parallel plane, and suppose this distance is small a, so the equation of the plane parallel to the yz plane is x equal to a. Similarly, we write here equation of the plane parallel to zx plane. So if we take a plane parallel to zx plane and this plane is at a distance b from zx plane, so equation of this plane parallel to zx plane is y is equal to b. Suppose that this board is zx plane and here this is the plane parallel to the zx plane and this distance is small b, so this is the y is equal to b. This is the plane which is parallel to the zx plane. Suppose this board is zx plane and this is the plane which is parallel to this zx plane, and distance between this plane and the zx plane is b, so this is y equal to b. So equation of the plane parallel to the zx plane is y equal to b, where b is the distance between the plane and the zx plane. Now we find here equation of the plane parallel to xy plane. So if we take a plane parallel to xy plane and this plane is at a distance c from xy plane. So equation of this plane parallel to xy plane is z is equal to c. Suppose that this board is the plane xy plane, and here this is the plane which is parallel to the xy plane, and the distance between them is c. So this is z is equal to c. So the equation of the plane which is parallel to the xy plane is z is equal to c, where c is the distance between the plane which is parallel to the xy plane. Now we find here equation of the plane planes perpendicular to the coordinates planes. So first here we have to find the equation of the plane perpendicular to the coordinate planes. So we suppose that any plane which is perpendicular to the coordinate plane yz plane, so equation of plane perpendicular to the coordinate plane yz plane, that is x equal to 0. We know that the equation of the plane yz plane is x equal to 0, and we have to find the equation of the plane which is perpendicular to the coordinate plane x equal to 0. So x equal to 0 can be written as 1 multiplied by x plus 0 multiplied by y plus 0 multiplied by z is equal to 0. This is the given yz plane. Let us suppose that equation of the required plane which is perpendicular to 1 is ax plus by plus cz plus d is equal to 0. Here we suppose that the equation of the plane second, this is perpendicular to the given plane yz plane, that is x equal to 0, and x equal to 0 can be written as 1 multiplied by x plus 0 multiplied by y plus 0 multiplied by z is equal to 0. This is the yz plane. Equation of the yz plane is x equal to 0, and this can be written as 1 multiplied by x plus 0 multiplied by y plus 0 multiplied by z is equal to 0. And equation of the required plane which is perpendicular to the plane 1 is ax plus by plus cz plus d equal to 0. So if the two planes are perpendicular, so their normals are also perpendicular. Since 1 and 2 are perpendicular, so their normals are also perpendicular. So normals are perpendicular, so the direction ratios of the sum of the product of the direction ratios of the normals is equal to 0. Here we use condition of perpendicularity a1 a2 plus b1 b2 plus c1 c2 equal to 0, where a1 b1 c1 are the direction ratios of one line, a2 b2 c2 are the direction ratios of second line, and both lines are perpendicular. So condition of perpendicularity is a1 a2 plus b1 b2 plus c1 c2 equal to 0. Here plane 1 and 2 are perpendicular, that means the normals of the one and normal of second also perpendicular. So we use here condition for perpendicularity. So a multiplied by 1 plus b multiplied by 0 plus c multiplied by 0 equal to 0. This gives a is equal to 0. So put a is equal to 0 in equation second, and we get the plane which is perpendicular to the given plane yz plane. So put a is equal to 0 and get the equation of the plane which is perpendicular to the plane 1 is by plus cz plus d equal to 0. So this is the equation of the plane which is perpendicular to the given plane yz plane, that is x equal to 0. Similarly, we find the equation of the plane. Similarly, equation of the plane perpendicular to the xz plane is ax plus cz plus d is equal to 0, and equation of the plane perpendicular to the xy plane is ax plus by plus d is equal to 0. So these are the equation of the perpendicular planes to the coordinate plane. If we have to find the equation of the plane perpendicular to the yz plane, so equation of the plane can be written as by plus cz plus d is equal to 0. This is the equation of the plane which is perpendicular to the yz plane. Equation of the plane perpendicular to the zx plane is ax plus cz plus d equal to 0. Equation of the plane perpendicular to the xy plane is ax plus by plus d is equal to 0. Here we can see that if we find here equation of the plane perpendicular to the yz plane, so here coefficient of x is 0. If we find here equation of the plane perpendicular to the xz plane, so coefficient of y is 0. If we find here equation of the plane xy plane, equation of the plane perpendicular to the xy plane, so coefficient of z is 0. Thank you.
Subscribe my channel.